Okay, good morning, everyone, and welcome to this roundtable webinar with TechCentral.ie, where we're looking at the challenge of quantum computing. I'm Niall Kitson, editor of TechCentral.ie, and I'll be your moderator for the next 50 minutes or so. The UN has designated 2025 International Year of Quantum Science and Technology. And you could be forgiven this is part of some marketing campaign for Microsoft and Google, who have announced new quantum chips in Majora 1 and Willow, respectively. On another level, 2025 gives us something of a wake-up call from a security perspective when so-called Q Day arrives, which is estimated for 2035, which will see the end of encryption as we know it, when quantum computing will destroy cryptography as we know it, exposing everything from text messages to Bitcoin wallets to public scrutiny and theft. Like it or not, quantum computing is coming, but opinions differ on its value, its reliability, and how long we have to prepare for it. To discuss how long we actually have, we're just joined by a stacked panel this morning from industry and academia. I'm delighted to welcome Marc O'Regan, EMEA CTO with Dell Technologies Ireland, Donal Óg McCarthy, EMEA Cloud and Application Security Lead with Accenture, Dr. Deirdre Kilbane, Director of Research with the Walton Institute, Professor Felix Binder, Assistant Professor in Quantum Science at the School of Physics in Trinity College Dublin, John Woods, CTO with the Algorand Foundation, and John O'Donoghue, Senior Global Solutions Architect with Equinix. Good morning, everyone.
Morning. Hello.
So, as always, with all things Tech Central, we like to get our audience involved as much as possible. So we will be running a number of polls throughout the coming hour, and we are open to questions from the floor as well, which will be moderated by our production team. So first things first, I'd like to throw it open to the floor. So Killian, if you could deploy our first poll, where we are asking the question, is quantum computing a part of your IT conversation at the moment? So we'll just give a few seconds for the votes to come in, and then we'll have a look and we'll see at what stage people are on their quantum journey, whether they've begun it at all yet, or whether maybe they're already on the road. Okay, Killian, if you'd like to give us the results on that. 50-50.
Wow.
That's actually a bit more than I would have expected. So it looks like we're in for a lively conversation this morning. So I'll get straight down to it. Um, for the panel, what do you think are what we'll refer to as the brilliant basics needed to architect a solution so you can be quantum ready? So what's the foundational work like? Do companies have to reevaluate their entire IT estate, or is this something that can be adapted to gradually? Marc, you're on the vendor side with Dell, so how do you feel about this?
Yeah, thanks, Noel. So first and foremost, that was one of the most surprising percentiles I've seen in quite some time. It wasn't. As CTO, I'm looking at our emerging technology, forward-thinking strategy as a company. I spend most of my time it'll be no surprise, in areas such as quantum architectures, AI functions and things of that nature. Last year, I spent probably 55% of my time both doing industry talks and in workshops with business leaders, technology leaders, talking about quantum strategies. And it reflects the numbers that came up there, which was pretty surprising and good to see. From the Dell perspective, I guess the brilliant basics. Do you have to rip and replace? I would say absolutely not. There's a common misperception that quantum computing is coming to replace what we call classical or traditional computing. This is not the case. We very much see a symbiotic relationship between, classical computations and what happens on the semiconductor and quantum computations and what happens on the qubit. So, it's very, very interesting around how we look at building such a hybrid system, such a hybrid compute architecture. But for those in industry with proficiency in classical computing, there's a number of different things that we can do. I think you nodded toward it there. It's looking at vendors or looking at partners, as I would prefer to put it, industry partners who have a level of proficiency and a level of strategic thinking around how to place quantum computing into your respective ecosystem. So, as well as the basics, there's going to be the gaps, I think. So, from a classical compute architecture perspective, we talked about classical computing, we talked about semiconductor, which of course is constructed on zeros and ones, and we understand that world very, very well. But the universe of quantum computing is constructed on a completely different language, and is brought to us through qubits. So how do we interpret what qubits are trying to tell us? If we look at a quantum computer and we're looking at dropping, atoms into a trapped state in order to actually try to get them to behave properly and tell us something of value, well, then that state has to be very specific. It needs to be near 0 Kelvin, which is minus 476 degrees Celsius, I believe. We need to look at a lot of different problems that have been exposed to us through quantum, particularly around error correction and how we handle these. But fundamentally, I think we need to be able to talk to the quantum system, and we need to be able to interpret what the quantum system is telling us. And this is where classical compute architecture comes in. If we can develop a way of having the classical compute architecture interface with a quantum compute architecture, that way we can extract the information from the quantum system to give us the information that we're looking for. It will also give us an opportunity to touch, to feel, to live in that quantum universe, using tools and technologies that data engineers and platform engineers and architects, IT architects, are familiar with. Things like Jupyter Notebook, things like Kubernetes orchestration engines, things like, excuse me, PyTorch and TensorFlow, frameworks of that nature, and being able to bind them into a software deployment kit and deploy them on top of classical compute architecture in a meaningful way. And then, just like GPUs, being able to interface with QPUs, quantum processing units, and using virtual QPUs in order to be able to abstract that experience. So if we can take the idea of an SDK and build tools and technologies that can land on top of our already existing classical architecture, I believe we can help people in IT, people in data groups, data scientists, data engineers, experience quantum in a meaningful way for their respective business, be they in a bank, in finance, in healthcare, manufacturing, or whatever that might be. It's then about finding the right problem that we're trying to solve with quantum, which is another problem within itself.
Donal Óg, the brilliant basics from your perspective. I mean, you're looking at things from a project management kind of a view.
Yeah. Thanks, Niall. And it's a good segue from what Marc said, actually, because I think while there's a lot of things we don't know yet, we definitely know the following. It's going to happen. It is real and we need to prepare for it. So I guess in my role in security and coming from a cloud engineering background, I'm very focused on the practical steps that one can take right now in a large enterprise, because all of the organizations I work with are complicated. They're old. They've been around a long time. They have a large legacy estate. They have lots of new things. So in that context, what steps can one actually take that are practical? And I think for us, it's really three things. The first is you definitely need a quantum strategy. You need to understand over the next 5 years, what am I going to do? What are the areas of my enterprise that I need to be particularly concerned about? Is it communication? Is it data? And is it in particular areas? And I think with that in mind, the second key step is you have to discover where your vulnerable encryption is, where your vulnerable areas of your enterprise are. There are lots of organizations that still have what we would call deprecated protocols, algorithms, things that they had in their long list of things they need to change. Well, actually, now is the time where you actually need to embark on a journey to change these things. Because actually, a really good design pattern in the past, before we were ever talking about quantum and the potential impact it will have, were always good design patterns. So in other words, there are legacy things we always needed to change. So you need to go out and put in the effort to discover, where are my keys, where are they stored, how are they recycled, when do they expire? If I already thought I had a problem with those things, well, I definitely need to now understand where all of this exists within my enterprise. And then I guess the last key step, and Marc kind of alluded to some of it there, is this idea of crypto agility. So there is going to be a moment, and we don't know exactly when that moment is, but we think it will be 2030 in Accenture. That's where we would say we have the next number of years to prepare, is where we're going to have to be able to swap in and out these algorithms, protocols in a very operational way. And anyone who comes from a software engineering background like me, would say that's a highly complex thing to think about now. But actually, when it comes to quantum computing, when it does eventually land and if our existing protocols are under threat, we certainly do know we're going to have to be able to hot swap in these algorithms and these protocols pretty quickly. And in our world, that we call that orchestrated crypto agility. Big words. Orchestrated means we can make the change. And the agility bit, of course, is that we can swap them in and out. So it's going to have to be something that in a current decentralized world is actually quite hard to think about, but it's going to have to be something we've control over. So this idea of crypto agility. And so I suppose in my role, it has to be very practical. So right now it's understanding where are these areas of vulnerability and what actions do we need to take over the next number of years. Those are the brilliant basics.
John O'Donoghue, coming from an Equinix perspective, does that ring true to you? Your microphone is off there, John. Yeah, have you now?
Is that better?
Yeah.
Okay, sorry. Yeah, I suppose from our perspective, we're looking at the foundational infrastructure and with our partners. So as Marc touched, cooling these systems is a particular challenge, and we're still evolving the technology to do so. So obviously adopting things like liquid cooling, which we've done for quite a period, but how do we do that at the level a quantum computer needs to maintain its state so it can absolutely provide the best service? And one of our stated objectives is around the democratization of quantum computing. So we've deployed a number of quantum computers within our data centers. So working with the likes of Oxford Quantum Circuits, the likes of Alice and Bob, and we're working with them around quantum computing as a service to enable that access to systems. And that's important for users to have that ability, because it's not within every enterprise's ability to actually deploy their own quantum computer. So by being able to provide it as a service enables more people access. And then very much the integration element. So we work with some of the quantum integrators such as BlueCat to enable to simplify actual access to the system, because the skills are limited in terms of coding in a quantum. And again, as Marc alluded to earlier, and Donal, how do we simplify actually running workloads and make it as similar as it is today for those users and not make it so difficult to access the systems? So kind of our core piece is enabling access to systems, and then also working with integrators to simplify the ability to actually run jobs on the system. And really, we're providing the network to do so, and then also the foundational infrastructure needed to host these systems.
Yeah, John Woods, if I could ask you there, one of your jobs is to convince people to start adopting quantum technology. As we've seen from our poll, it seems to be a 50-50 split, certainly with IT end users. Are you finding similar challenges out in the world, for want of a nicer way to put it?
Yeah, and maybe I could just quickly step back and say, quantum computing is not, a general purpose compute solution. It's good at certain things. We have a number of algorithms that we have theoretically understood that allow us to speed up certain operations. For example, factorization of numbers, or searching in unordered sets, those types of things. And so, like Marc kind of suggested, I would see quantum as kind of a specific purpose card, like a GPU. It'll be a very long time, of course, due to the physical constraints until we get to that kind of point. But it'll be something that you will add to a classical computer, I would think, to speed up very specific operations. And so I do think that Dell's business model is safe for now, thankfully. Yeah, maybe I could also just say, because of these algorithms that we're aware of, where we can factor numbers quickly, or we can kind of look through unstructured data sets more efficiently, we know that certain types of cryptography will be broken. And so, it's not all cryptography. Quite specifically, it's the asymmetric branch of cryptography where, things like elliptic curve cryptography that we use in cryptocurrencies where I work, but also, in TLS or in modern websites, right, to secure the connections. Quantum computers can basically solve the discrete log problem, which is the mathematical trapdoor that elliptic curves use, in a polynomial time. And then they take something like RSA, which again has been around for a very long time, and people will probably be familiar with using it over the last few decades. That also has a polynomial time solution with quantum computers. But that's not to say all cryptography needs to be replaced. Symmetric cryptography, i.e. the idea that you use a key to encrypt a piece of data and maybe sitting in a database, that is essentially safe. And by the way, there's this notion going around that Grover's algorithm, which is one of the quantum algorithms that attacks symmetric cryptography, essentially reduces the bit strength by the square root reduces the bit strength of symmetric primitives by their square root. That would be turning, say, AES 128 into AES 64. But that's not actually the case, because Grover's algorithm may be able to find an AES 128 key in 2 to the 64 operations, but they're quantum operations. They're hard to parallelize, and they're non-trivial. And so I would say largely, outside of collisions for hash functions, which are basically the cubed root of the bit strength, I would say cryptography, as we currently understand it, is fine, except for the asymmetric branched public key cryptography, elliptic curves, and RSA that we discussed before. At Algorand, we have already brought PQ, or post-quantum cryptography, to production in a multi-billion-dollar product. We've added lattice-based signatures, Falcon signatures, to our production network. And it's quite a hard thing to do, because there's lots of functional and non-functional requirements you're trying to solve for, and it introduces complexity to your stack. I would just say that people need to take it seriously, in my view. I think if you look at the big companies out there, Apple, Google, etc., even OpenSSL, these companies are adding these primitives, these cryptographic primitives, to their existing stacks, like PQ3 with iMessage, or Kyber in Chrome, or whatever. And these things are not being added to those code bases for the fun of it, or for a technical flex. They're doing so because these companies think that there's a credible threat with quantum, and I agree with it. And so, yeah, I would say that when you're bringing something like this to production, again, kind of echoing what Marc said, it's not a kind of a rip everything out and replace everything. It's rather a nuanced assessment of your current architecture. What are the weak links that I have to kind of replace with a post-quantum primitive, and then applying that in an appropriate way. But there's lots of trade-offs. As an example, when we use Falcon, it's a digital signature scheme, right? Just like RSA is, or just like EDDSA is. The public key is much bigger than elliptic curve public keys. The signature time is much bigger. The verification time is much longer. The signature size is much bigger. And this adds to like data propagation bloat, compute burden, etc. So, these things are kind of, it's quite nuanced. It's not a case of just replace everything carte blanche. You will have to make kind of like trade-offs here and there. But I do think for sure it's something that we have to take very seriously, not just in cryptocurrency, but certainly with the web the world over, privacy the world over, and security the world over.
Deirdre, in our conversations before, you talked about companies sort of approaching you in SETU, basically sort of dipping their toe in the water, looking at, okay, well, what can we actually use quantum for? Do you find that there is that sort of similar charm offensive required, particularly when it comes around to security?
Actually, I've been quite fascinated. Over the last 2 years, we've been running the Ireland QCI project, and I see huge advances listening to the speakers here today. Everybody talking about having their own quantum strategy and being ready within 5 years. We're mainly focused on building out quantum communication infrastructure for Ireland. So the project that we're running is the Ireland QCI project. And within that, we have several quantum security use cases. We do get engaged with different companies on these, but the use cases are deployed in different locations. The communication infrastructure is being built between Tyndall National Institute in Cork and Walton Institute in Waterford and Trinity College Dublin, where Dan Kilper is the director of the Research Ireland Connect Centre for Future Networks. So in each location, we kind of focus on different, I suppose, offering different services or different possibilities for companies to come in and look at the different technologies that we have. So Marc mentioned, I think, using cryostats or having devices at millikelvin temperature ranges. Well, in each of these locations, we have cryostats, and the idea is that companies can come in and understand what the technology is, the requirements, even in terms of how you would kit out a laboratory in your own company to facilitate these types of experiments to see, can you actually manage to have your own qubits, and then look at securing your different, I guess, assets in the company. Of course, a lot of the security, you have to remember the level of security you require as well. Do you require the highest level security for everything, or is it just maybe for IP? We're looking at securing communications between different organizations as well, with the focus being on government, industry, and academia. And then really about testing out different devices for the future of quantum. So not just focusing on, commercially available quantum key distribution devices, which each company would be already looking at as a hybrid solution with the post-quantum cryptography algorithms. This is all part of the plan for the EuroQCI, which is a pan-European quantum communication infrastructure across the 27 member states. In the initial phase, each country is focusing on building out the backbone network across different locations. And then in the next phase, we'll look at interconnecting the different countries. So it's quite interesting to see all of the advances being made in securing against attacks that might happen with the advances in quantum computers. But you'll also see by building out these quantum communication infrastructures, we're also trying to develop the most advanced applications. The most advanced application, for example, would be distributed quantum computing. So if we're not just looking at commercial quantum key distribution devices, we're also looking at devices that can offer multi-point to multi-point QKD. And then we're looking at building the technology for developing the quantum internet. Like I talked about with the cryostats, we can also look at the interfaces that are needed, the quantum memories that are needed, and the quantum repeaters. Because as Marc mentioned, the qubits, they require these very low temperatures, and they're very fragile. And when you send qubits down a certain distance on a classical fiber, for example, it will interfere with the classical signal, which will be much more powerful. There'll be crosstalk. Sometimes you have to have a dedicated dark fiber for these. In our project, HEAnet are offering the classical fiber, and ESB Telecoms are offering the dark fiber for us to do the experimental testing that we're doing in the project at the moment.
Felix, I know you're coming at this from a much more theoretical perspective. Where do you find the conversation is with companies at the moment? Again, is there that toe-dipping thing, or is there enough awareness that the likes of Q-Day is coming and people have to treat, if nothing else, then their security with much more seriousness?
That's a very good question. Thanks, Niall. So I've been doing full-time research in this area for about 15 years or so, and it's really, amazing to see how the technology is changing so rapidly, right? I run a master's degree here, so we're trying to educate the next generation of experts in the field, and that's of course being directly influenced by where the technology is and what companies need. So maybe to take a step back to speak to maybe both of the 50% of the audience. We're talking mostly about quantum computation here, which is one of the main, the largest market size quantum technology. There's also quantum communication, which Deirdre was just speaking about, and there's quantum sensing, which is the most mature, but maybe the smallest market size. So let's leave this aside. Quantum computation is currently at the stage of, which is pre the first financial value being generated from it. That's at least the sense in the field, right? So quantum computers can currently do stuff which classical computers could not do in any realistic time scale. They have done scientifically interesting things. They haven't done anything that's of commercial value, right? And this feeds into at what point should we be worried about something like Shor's algorithm, which can become a threat to certain encryption algorithms, as John Woods explained, becoming realistic, right? So this factoring is in a sense is the killer application of quantum computing. It's good to keep in mind that that's one of the later applications that will actually become a reality, because it requires some of the largest fault-tolerant machines, the types of quantum computers where you as a user don't have to worry about the noise, the physical environment that the quantum computer sits in. And so I'm not a futurologist. The NSA says to get prepared sometime in the early 2030s. I'm sure they have experts on estimating when exactly to pick that, what you're calling Q-Day. I would imagine that we'll be updating this year as we go in either direction. But again, this is one of the things. So where this might seem as a threat. So if you're using cryptography currently, this is something to be aware of and protect against. There's also a whole range of opportunities, and this depends largely on the field that one is in, right, as a company or as an individual. So the first things that we think will be likely uses are quantum computing deployed on quantum systems, so in material science, pharmaceuticals, etc., where you try to describe something which in itself, a molecule or something, follows the laws of quantum mechanics. And then the sort of more digital versions, uses of quantum computers come in later. And this has been explained. So this is exactly the right picture as Marc O'Regan was describing, to think of this as a QPU, so something that slots in with other forms of computation. So GPU, neural processing units, whatever you have. And this is relevant if you're trying to approach this, right? So as a company, you might currently try to get a physicist on board that can tell you how these different hardware technologies, what stage they're at, how to speak with them, what platform to use. Chances are, by the time this actually becomes a reality to you, this is not necessarily the skill that you require anymore. But again, this depends on what you're looking to get out of quantum computing. Because currently, if you use some abstract function in Python or something, let's say in NumPy, few people will know how NumPy actually computes this under the hood, and for a lot of use cases, this will be similar. So maybe the relevant role currently is to get a good estimate as to the specific things that are relevant to you as a company, at what stage they will become realistic. This is called resource estimation. So to get a understanding of what size of quantum computer will make a difference for a specific use case, right? And this depends on what use cases someone has. So maybe this just to draw the bigger picture here. From the side of, I'm assuming the audience is mostly not from the side of quantum computing or related fields, and trying to figure out where to slot into this. So it's a very good time, I think, to build up expertise. We're not acutely worried about this, but we should be getting our expertise on and try to either speak to external experts or see if there's someone that we can bring in-house. Again, it depends on what a specific company does, let's say. Yeah.
let's throw things open to the floor for our second poll of the morning. Killian, if you'd like to deploy that for us now, where we're asking the question, what is your biggest barrier to becoming quantum ready? Is it a lack of budget? Management don't understand its potential? A shortage of talent? Access to technology, or it's hard to demonstrate return on investment? Now, I'm sure a lot of you could probably tick more than one box in there, but let's just get a sense of the lie of the land. We'll give it another second, and then we'll throw up the results there. Okay, Killian, if you could give us a lovely looking pie chart for that. Lack of budget, management don't understand the potential, shortage of talent. Okay, well, it's a tight call, but the problem seems to be one of management at the moment. Marc, are you having discussions with people at that C-suite level who are just kind of shrugging at the prospect of quantum and thinking this is one for the guys in the on the server room floor, this is one for the nerds, it's not really for us?
The short answer is yes, we absolutely are. I think again, they're really interesting statistics or excuse me, percentiles that have come up in front of us. But I think understanding where the return on investment is will pair into the management's understanding of where they can actually extract value from quantum computing. I think it's important though, and most of the speakers covered this, and Felix in his last points being made there. It really is understanding the different areas of quantum computing and quantum technology itself. Felix, you mentioned sensors, which is an extraordinarily interesting and probably the most successful area of quantum, I would think, so far. But there's other areas also, quantum comms, communications. And from the computing perspective, there's different areas of quantum computing as well, or at least different approaches. So there's many ways to skin a cat, as we may say. And I think from my perspective, or from our perspective, when you look at it, there's analog, where we look at annealing, and then there's gate-based quantum computing. But we've leaned into annealing as our area of focus, where we actually try and take a trapped ion and, and Deirdre alluded to this, bring it into the environment where it's comfortable, where it can behave. And you're absolutely right, Deirdre. This is what we found. You take one atom, you drop it into its perfect environment, it'll behave very, very well. And then you drop in others, it starts to misbehave. And it reminds me of a lot of the work that most of us on this call would have done over the last 10, 15 years with neural networks. Neural networks, as they start to, grow, as they start to scale, they start getting a little bit narky. And we have to, massage them and make sure that they're, where they need to be in the state that they need to be in order to produce good data and good information. So back to quantum. Yes, I think if you can bring a vision, if you like, or a roadmap to the C-suite to say, well, look, quantum is this distance away, but preparedness is the area that you should focus on. And we can tell you that, and again, back to Felix, you're quite right. We haven't hit that virtuous cycle that we hit with semiconductors. So if we go way, way back to the dawn of computing, we would have had, full addatron, which brought us from, the mechanical and vacuum era into the semiconductor era, and then from the semiconductor era heading toward what obviously Albert Einstein called strange or weird computing, into that quantum space. Now, what we haven't found is that virtuous cycle is where we have fundamentally and economically a better set of use cases for quantum computing that will overleap those of semiconducting computing and classical computing. Now, this is back to that symbiotic conversation that we had before. So as C-suite, what we do have on our lap, under the hood, are experts in data, experts in infrastructure, experts in data center with John and his team. So how do we leverage this, and how do we bring somebody with a level of expertise from the quantum area into that fold, into that environment, to give us access, as John O'Donoghue said earlier on, give us access to the technology so we can dip our toe and experience, taste, feel, what this quantum architecture looks like, and explore where it could add value to us. So I can't remember which one of the speakers talked earlier on around optimization problems that we could be solving. I think it was Donal Óg. That's certainly one area where we can look down into supply chain, where we can look at, in healthcare, and one area, I'm just back from Saudi Arabia last week, where I spent a week with two organizations, one governmental and one was a private organization there, where, this is my third trip with one of those organizations to talk about doing exactly that with the C-suite. How do we take a high-performance compute cluster, carve that cluster off, and then take software in order to be able to expose the components of the hardware and present that as a simulated quantum system that we can actually start to play with, start to test with. And that is certainly an area that Dell Technologies have made great strides over the last 3 to 5 years in bringing together the, as you call them, the brilliant basics, and compiling them into a deliverable system that take everything from virtual QPUs right through to the SDKs that bring in, technologies like Circ, and I mentioned them earlier, PyTorch and TensorFlow, all of those frameworks, all of the APIs that we need from the technology, from the classical technology level, and give data scientists and data engineers that chance to be able to load jobs using a regular Kubernetes-driven orchestrator onto a simulated platform and work with that platform for a specific period of time underneath your own firewalls and the security of your own firewalls. Now, here's where it gets really, really interesting. I think then the next step would be to use that simulated platform to be able to bounce onto true qubits. So that would be able to consume and get qubit time on a platform run by, for example, INQ, which are a partner of Dell's. So now we're going from a simulated platform onto consuming real qubit times. And that could be a roadmap that makes thorough sense, in my view, to C-suite when they're looking at, well, we have real investment in people who understand data and understand how to extract information with data, real investment in scalable technologies where these people who understand the data and people who understand the technologies can build some sort of a simulated quantum experience. Now we're investing in bringing in the quantum expertise in order to galvanize that and to build a quantum program and project. And we have a roadmap now to bounce onto a true quantum platform when the time is right for us to do so. There's one final point in this that I have seen and that I thoroughly believe, I'll be interested in the others' opinion on this as well. We are heading towards a time, yes, be it 2030, be it 2036, whenever it is, we're heading toward a time when RSA will be cracked, when the post-quantum era will be upon us, and we need something to respond to that. That's a given. There's no two doubts about that, and Donal Óg expressed that at the very top of his talk. It's also, I think, pretty clear to me that we're racing toward an era where artificial intelligence and AI functions, things like AI agents, which we're seeing a lot of over the last 12 to 24 months, those agentic workflows that are turning up in our architectures today, and how they are starting to build a world of cognitive applications. And I believe that if we live in a world over the last 30 to 40 years where we would have had monolithic and cloud native, and we could even bring edge native applications into that fold, where we would have traditional and cloud native applications being powered by classical compute architecture, I believe that we're seeing the emergence of a world where we're looking at cognitive events and applications being built through AI tools and technologies being driven through the acceleration of quantum platforms. Now, that could be a little bit out, but all the more reason for C-suite to move ahead of the curve, get around the corner of trends and partner well, and double down on their investment in their infrastructure, in their resources and capabilities, and understand what it is that quantum technology can do for their business and their organizations and their societies, I must say. This isn't just a business or organizational conversation. This is a societal conversation, which is, you know, extraordinarily important to have, you know, at government level. And be prepared for when, you know, when these events arrive.
Yeah, and
Donal Donoghue,
sorry,
if you'd like to chime in on that.
Okay, sorry, I'll let you go first.
Yeah, I mean, reinforcing what Marc is saying, really, I mean, that kind of the preparation for it. I mean, it wasn't that long ago we kind of have what you might call a flashpoint in AI. I think ChatGPT kind of brought it to the masses and what the potential of AI is. We don't really know when the flashpoint at quantum will emerge, but the investment into this technology is accelerating, and we will see use cases that emerge. What we tend to be seeing is it's very industry specific. So within the finance space, an enormous amount of our customers, you know, they have quantum practices, very secretive about what they're doing, but they do have quantum practices, and a lot of them have very specific requirements that, you know, their data, they need to keep their data within their four walls, and that's where we're working with them around the deployment of quantum systems in our data centers, which is ultimately their four walls within their cages within our data centers. And we're also seeing the emergence in pharma. You know, you have the likes of BASF in the quantum space, who are specifically looking at chemistry models and how quantum can be applied within the chemistry space. And logistics is actually the third industry where we see big investment. And we actually did a survey with the S&P 500, and these were kind of the emerging trends, which kind of reinforce what we're seeing utilize our service. And what we're doing is trying to help customers prepare in whatever industry in terms of access to systems. So we have over 30 services, 30 quantum services now within platform Equinix that users can consume. And they vary in terms of their use cases, but it means low investment to enable, you know, and it goes into that business case building, as Marc said, you know, presenting to and creating a roadmap in terms of access to systems. We're trying to help customers enable them that with low investment, and by being able to access multiple systems and begin to access different services and see just to touch their toe into the system and figure out what they're going to be doing in quantum. But again, I reinforce that. I mean, if you don't start preparing now, there's a good chance, you know, you're going to miss the boat when quantum truly emerges and we start seeing use cases become prevalent in everyday society. And they'll become differentiators between the organizations that prepared now versus the ones that didn't. And we're already seeing that in AI, and we're going to see the same trend emerge.
John Wood, sorry, I jumped in there on you.
Yeah, no, nothing much more to add. I was just going to say it's interesting to see that poll. Interesting to see that people, you know, the two things were selling it to the board or to your executive team, and also, of course, talent, which is a thing, because the mathematics is hard, the engineering around this stuff is hard. Crypto is hard in general. Like cryptography implementations are hard generally, I would say. This stuff is maybe a level above because it's even less well known, less well trodden. I would just say though, you know, when you're framing this, doesn't matter what your business is, whether it's a SaaS business, a hardware business, you know, you're running a website like Salesforce, doesn't matter what the business is. You know, you just have to frame it simply by saying, you know, our reputation as a firm is probably our most valuable asset. If you're going to have a pretty bad day if people's data leaks, right? And I don't think it's hard for an executive team to understand that. Now, maybe they won't understand multivariate math or lattice-based n-dimensional spaces, but they can understand that. And so I think it's a very easy sell, actually.
I would just
Donal
like
Óg,
to,
if you'd like to add some. Oh, sorry, Deirdre. Go ahead.
I was just going to come in there on the bit about talent and skills. And, you know, it's great to see the government has put forward its Quantum 2030 strategy, and they're hugely invested in quantum already. So the Ireland QCI project is co-funded by the European Commission, and 5 million euros co-funded by the Department of the Environment, Climate and Communications. So they already have it embedded in their research strategies as well. So it's cross-department at government level. And one of the main parts of the project is about educating not just a workforce, but raising awareness with key stakeholders from industry, academia, and government. So we run workshops and training sessions in our quantum facilities in Dublin, Cork, and Waterford. And all you need to do is get in contact. It's for anyone from the government sector, from industry, and from academia. And we can cater it for all levels. So you mentioned there, is there a gap between maybe the technical people in your company and the senior management? But the ideal audience is to bring people from both to one of these workshops, and we can engage and do as much explaining as necessary, and really looking at the benefits as well for humanity.
Felix, we talked briefly in our prep for this session about the value of talent. In terms of students that you're dealing with, is there an appetite for working in industry, or are people still interested in staying within an academic setting?
That's a good question. So, and I would say that there definitely is, and it's increasing, the appetite for industry. We are currently taking in on this master's program. This is one of about in the 60 to 70 master's programs on quantum tech in the world. One of the few that does the theory application side only and doesn't focus on the hardware. Currently, we take in about 50% Irish folks into the degree. We keep about the alumni that we know where they've ended up, which is the majority. About a third or so of them stay in Ireland. So this is Irish or non-Irish folks who take up a PhD or work for a company here. We have a few specialist companies already in the country, but the Irish economy is a little bit behind compared to other countries, especially other smaller countries that have gotten onto this early on. So currently we have more talent in a sense available here in the economy than the economy is supporting. This is rapidly changing. We're not worried about this. We're also very happy for these young folks, if they've already done their undergrads here, to go see the world and join a quantum startup in Paris or Helsinki or wherever they end up going. It's a flux in both directions, right? But so if you're looking for someone who's got an all-round full expertise in this area, we do graduate about 15 to 20 people in this area each year, and they're very interested in industry roles. Most of them will be interested in going into quantum-specific companies. That's where the excitement is at the moment. But there is an openness, and there's a talent pool as well. Yeah.
Maybe I could come in on that one, Niall, for a sec, just because, Felix, this is really, I think anyone who's in this country that hears we have too many of a certain skill would be fantastic. So thank you for that. I guess there's a couple of points I'd love to make around what we're hearing with board level, and then talk a little bit about talent, as you and Deirdre have commented on. I guess it depends on who you talk to in each organization, what they want to know about quantum. So the CISO is definitely worried about steal now, decrypt later, let's say, and I'm giving them one example of each. The CTO is definitely worried, do I have quantum resistant architecture built into my enterprise architecture in the places that matter? I think it was multiple people here have said, you need to focus on where it really matters, because it's not going to be everything and everywhere. And so that's where the quantum strategy that Deirdre and I referred to earlier is so important. But then the last person, of course, and the key people that hold the budget is the CEO, the CTO. They're worried about threat that quantum can bring. They're also worried about the opportunity for their organization. And so in the sessions I run for lots of organizations based in Ireland and in Europe, it's very targeted at what is immediately their concern, to try and have both the yes, there's something you can be worried about, but there's also something that gives you amazing opportunities. And how do you think about both? And in our organization, I mean, we've 700,000 employees globally. So how do we educate ourselves in quantum in a way, just as Deirdre talked about, that sits at everyone's level? Because we have deep scientists in the dock in Dublin, and then we have people in security, technology, marketing. So we do a thing called technology quotient. So everyone has to be trained in quantum globally, and you have to do it. And it's at a very base level, but it does mean you have this level of fluency and awareness across the organization. And then it's for everyone to kind of dip their toes into the bit that's really relevant to them. So our industry leaders will focus on, well, why does it matter to a retail bank? You know, and of course there's risk and regulation and all the other stuff that comes with that. So that's kind of our version. And of course we do that with clients as well and with boards. But even last week, I was running a session for a board of an insurer in Europe. And the quantum, in fact, it wasn't on security and it wasn't on quantum, but they asked me the steal now, decrypt later question. That was the one thing that was in their heads that they had gleaned from a previous security session. So I think that return on investment and that whole idea around do the senior leaders understand? I think they understand different things, and I think you have to craft the message slightly differently, but it's totally doable. I wouldn't want anyone to come on this and think, I've got to be an expert in quantum to navigate the conversation. You definitely don't. You can have a really good conversation around being ready and taking really positive, clear steps forward now that prepares you for what's coming without having to necessarily have the depth that my amazing colleagues here do. So there are really practical things you can do straight away, I think would be my advice. Thanks, Niall.
Lastly, a very quick question for the panel because we're in danger of going over time. When it comes to managing risk and regulation, as you raised there, Donal Óg, it begs the question, at what level do you start regulating? Do you regulate at the industry level and hope people behave themselves? Do you regulate at the national level and hope that expertise catches up in the public sector to understand what's happening? Or once again, do we have to look towards Europe to impose not only standards but penalties when it comes to security and management in general? Very quickly, across the board, I'll start with you, Marc.
Yeah, I think the easy answer to that is at all different levels. But I think Europe has taken the lead globally with AI and AI governance and regulation. And I think they should take step for their 2068 program to reinforce that with quantum as well. It's extraordinarily important, and we do have to remember that quantum, and again back to what we said at the beginning of the webinar, quantum is not going to solve for everything. It is going to be part of the capability, and there's things that we're struggling with at the quantum level, right? At the quantum computing level. Error correction is still not near where it needs to be. We've still experienced quantum doing extraordinary things. I mean, we've had Willow last year being shut down by Google because it was starting to speak in an unknown hieroglyphic type of language. What does this tell us? This tells us that quantum computing can do extraordinary things, but can very, very quickly scale outside of regulation, outside of control, in the very, very same way as AI and particularly AI agents can. So having regulation, and this is where I believe, by the way, Niall, that where artificial intelligent agents are hooking into policies and into local and governmental policies. We're doing something with Accenture right now at the moment on verifiable computing, where we're looking at, taking every single computation from an execution and running it to the silicon and then verifying it at the silicon level. And then using artificial intelligent functions able to ensure that we're maintaining GDPR and EU AI Act when it comes, but also local policies and governmental policies and policies that are being injected into that event potentially by the private enterprise themselves. So I think it's extraordinarily important that we go from from bottom up to top down on the governance piece. It's a really, really important piece.
Donal Óg, Accenture was mentioned. So what's the official Accenture position?
What's the
Or your
official
own?
Accenture position? That's a good one. I think, I mean, even if we look at the way, has Gen AI and its adoption followed regulation? And I mean, clearly not, they're out of sync. I mean, there's a danger for quantum, the same thing happens, but I think I would probably agree with Marc. I think we certainly don't forget our role with Dell, with Equinix, with all of our other ecosystem partners, that we have a role in influencing how this should be done, because we are equally involved in lots of the projects we do jointly with both those organizations and others. We're working in pharmaceuticals around molecular comparison. We're doing all sorts of quite deep things in the quantum space. And so we have a role to influence what that regulation should look like. Within the EU, there's lots of things happening around the EU Quantum Act, around the quantum communication infrastructure that Deirdre alluded to earlier. So things are moving, but I think there's going to be, a bit like when AI was adopted, we have a responsible AI framework. There's going to be a lot of responsibility on us to do this in a way that has very strong governance and accountability, and that's what we're doing. While we support governmental organizations in getting ready with risk and regulation and practical regulation, I think that puts the right controls in place, but also encourages exploration and experimentation. I think that's always the challenge with regulation, I guess. But I think we all have a role to play in influencing that right now, because perhaps now is the time to influence that.
It might be worth keeping in mind sort of what needs regulating here, right? In a sense, we don't directly regulate what a specific CPU is allowed to do or not, or meant to be constructed, or a GPU. I'm sure loads of regulations apply technologically, but I think the regulations that we should be looking out for apply to computation, AI, etc., right? And it's worth bearing in mind that quantum computers are singularly bad at big data. So data loading is one of the strong constraints and bottlenecks. So GDPR type of considerations are probably very, very long downstream and apply to the entire computational mechanism, so the entire infrastructure. So probably the quantum itself doesn't require that much individual regulation, but it requires a bit of a geopolitical thought, because it's being understood more and more as a national security question, and countries are more and more fencing off their infrastructure, as are private companies potentially. So maybe that's a thing to look out for, in addition to sort of negatively regulating that. We're in the EU, we're in Ireland, we have close ties with the UK. What will these countries and blocs do in terms of sort of actively pushing native or local technology? We might not like that, right? We would like the technology to be global. These are just barriers, but this may well happen, like with the European Chips Act, etc.
Yeah, I was just going to come in there about the technology and the hardware. There's huge efforts around the world to make sure that the devices are standardized. Otherwise they won't be adopted, by different users. So there's different groups like ETSI and Sensenelic that are really focused on creating the standards and certification needed for. At the moment, they're focused on QKD, quantum key distribution devices, but they are moving towards trying to standardize the more advanced systems towards entanglement networks as well. But that's a good bit away. But it is really necessary for adopting the quantum technology.
John Woods.
Sorry, yeah. So I actually have a slightly different view. I think that we wrap ourselves in a total mess in the EU with regulation. I think I've worked at the European Central Bank, I've worked at the Irish Central Bank, I've worked close to regulators. They haven't got a clue what they're doing most of the time. Certainly not when it comes to this stuff. I can guarantee you that. And if you look at the regulation in the US, okay, around elliptic curve cryptography, which we've been relying on for a long time. The NSA and NIST standardized in the US P256, this standard elliptic curve. It's in your iPhone, it's in your Google phone. They still haven't explained the B coefficient on that curve, and I suspect with all of the work that I've done over the last 15 years in this stuff, it's probably backdoored. The NSA notably backdoored with the Snowden revelations, standardized deterministic bit generators. I have absolute distrust of government organizations standardizing this stuff. They've been proven time and time again not to be trustworthy. And I would say if you looked at modern cryptography today, the curves that are now just getting into TLS 1.3, they are ones that have come from the academic and cryptographic community, people like Daniel J. Bernstein, Curve 25519, ED 25519, etc. So, in short, sure, regulation can be useful in food and pharmaceuticals in certain contexts. I think in AI and in cryptography and science and math, typically regulators don't fully understand it and they make suboptimal decisions. And so I would say, learn this stuff yourself, understand the math yourself, and then you can make the appropriate choices.
John O'Donoghue, I'll leave the last word to you on this.
Yeah, I mean, regulation's a fine line between innovation and hindering innovation. And I do agree with kind of what John is saying there, in the sense that, we've seen that, anyone watching the interviews in Congress of Mark Zuckerberg and, you know, politicians asking technologists questions, you know, it can be comical to an extent, their lack of understanding of the fundamentals of technology. But I do think regulation is vital in these spaces, just like it is in food, etc. We need regulation to protect people that don't understand it. But I do agree with the idea that the people that are devising the regulation, they need to be the experts in the space, and the government do need to listen to the experts in the space around the regulation. But how you do that effectively, I'm not sure. Traditionally, what we see in Europe is Europe regulates and every other country does a copy and paste to the bits of the regulation that they like. You know, we saw that with GDPR. So Europe are, you know, we're experts at convoluting regulation, and it's important that we get this right, you know. But I do think regulation is absolutely important. I don't know the best mechanism for defining the regulation, but yeah, and that's a challenge that faces, and it's only going to get more complex as these technologies get more and more complex.
Just one comment on that before we finish up. I think I agree. I know exactly where John Woods is coming from, John. I know exactly what you're saying, and there is a fine line between heavily regulating something and then getting innovation where we need it to be. That is a real problem, not just in conversation that we're talking to today, but in general in technology. What I would say though is that I do believe that at a global level, we need to regulate AI, or we at least need to be part of that conversation. It needs to be democratized. And you can see with some of the work that, for example, even in this country with Barry O'Sullivan, with Professor Barry O'Sullivan and the team that worked together in order to actually, you know, funnel the data and information that was used for the 7 pillars for the EU AI Act. It's coming from canons of academia and the corridors of academia, as well as parts of private sector as well. I think there's definitely change needed there, but I think the more democratized and open and transparent that can be, the better for all of us, because this technology has the power to do extraordinary things, as we're all learning, particularly this year.
And that brings us to the end of this morning's session. We ran slightly over, but I think it was definitely worth it. I'd like to thank our panel: Marc O'Regan from Dell, Donal Óg McCarthy from Accenture, Dr. Deirdre Kilbane from the Walton Institute, Professor Felix Binder from Trinity College Dublin, John Woods from the Algorand Foundation, and John O'Donoghue from Equinix. We will have a recording of this event available on YouTube, and of course, you can keep up to date with the latest news for IT professionals and beyond at TechCentral.ie and on our podcast Tech Radio. Our most recent edition actually features an interview with John Woods that I hope is worth revisiting. And of course, you can find that on Apple Podcasts, on Spotify, or your podcatching software of choice. Also, please sign up for the Technology Minute newsletter to get all the news of the day direct to your inbox, including notices of webinars like these, and do follow us on LinkedIn and Facebook. For the team at Tech Central, I'm Niall Kitson. Have a great day, everybody.
Thanks, folks. Nice to meet you all.
Thanks.